All right, so we're looking at spread in box and whisker plots. So spread is the variability of data. It's also known as the dispersion of data. And basically looking at, in particularly, visually, it gives us a lot of insight into the distribution of data. And the main focus is the interquartile range. So the main focus is the interquartile range whenever we focusing on that. All right, so let's write that down. So the first thing is we're looking at spread in box and whisker plots. So the key words here, whenever we look at spread, is we are measuring, basically referring to the variability or dispersion of data points within a data set. All right, so we can represent it visually using a box and whisker plot. And the key component, so the main thing we have to first look at is the interquartile range, the IQR. Interquartile range represents the central 50% of data. And it's calculated by taking the upper quartile minus the lower quartile. So by calculating this, it would give us information about spread. The larger the interquartile range, the greater the spread, as a rule. So larger interquartile ranges, larger spreads. Among the middle 50% of data, while a smaller interquartile range means less spread. Likewise, the opposite, right? Smaller interquartile range would mean less spread. Now, there's also the whiskers. If we look at the box and whiskers, the whiskers extend from the quartiles to the minimum and the maximum values. And within a specified range, sometimes it's about 1.5 times the interquartile range. So if we take 1.5, the number 1.5, and we multiply it by the interquartile range, right? It's going to extend in and out on either side of the interquartile range. So I've got my box and whisker plot over here. And we're saying that these whiskers can also help maybe identify where this spread would reach. So if my lower whisker, all right, will extend to the smallest value, which will be over here. Let's call it A. Is going to be given by my lower quartile, which is Q1, minus from 1.5 times the interquartile range. So if my interquartile range is, let's say, 10, then 1.5 will be 15. And let's say my lower quartile is, I don't know, 40. Then this would be 40 minus 15, which will equal 25. And that'll be my lower whisker. It's almost like a lower bound. All right. And then if I go to my upper whisker, basically looking at where it lands on the whisker itself, I'm going to call this one B. We would do the same calculation, and we would take Q3, and we will plus that same amount, whatever Q3 is. So if Q3 is, let's say, 65, we would take 65 plus 15, and that would become 80, and that would be my bounds, you could call it, up bound and lower bound. And now, the significance of this is that whiskers help to visualize the spread of the data outside of the quartiles. And then whatever lies on this side and on this side, we can identify as outliers. It helps to identify outliers because now you're stretching the interquartile range, which is the middle 50%. You're extending it a little further. And so if there's anything else on the outside, I mean, it's a little too far from a centralized data set, which is where everybody's data is collected. So majority of people will have this characteristics because they lie in the middle from here to here. And these will be extreme, lower probability cases where things are not likely to happen. So we focus on the interquartile range because that's where the majority of any study that we are doing would be observed from. And so it would have a lot of weight in making decisions if we were to do a study and we end up looking at just the interquartile range and we extend it a little further to these upper and lower bounds as well. Okay, then there's the outliers. Okay, so let's have a look at outliers. So outliers are points that fall outside the range of the whiskers, like I said, right? They fall outside of Q1 minus 1.5 times IQR and Q3 plus 1.5 times the interquartile range. And so the significance of this now indicates that there's variability in the data, and then having variability in the data will affect the overall analysis of it. So if data is variable, it gives us an indication of the variability of it. Okay, we'll try and see an example in it. So we do a visual representation. We got our box, we got our lines, we got our whiskers, we got our dots beyond the whiskers, which represent outliers, for example. All right, let's have a look at, I don't know, simple set of numbers here. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 100. Okay. The first thing we're going to do is we're going to calculate the quartiles. So let's look at the quartiles. I've got how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. And my quartiles, remember, would be a quarter of the way. So let's count 5. 1, 2, 3, 4, 5. And another 5. 1, 2, 3, 4, 5. Okay. So we go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And that means my median is going to be 5.5. I'm looking at my lower quartile and looking at these numbers on this side over here. All right, so where would that be? Lower quartile. I got it right. I got enough all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So there's 10 numbers there in total, 5.5. So it looks like my lower quartile will be 3. And my upper quartile will be 8. And so from here, we would get our interquartile range. And that'll equal 8 minus 3, which is equal to 5. Now, if we're looking at the whiskers, let's say we had to find the whiskers using this data set. We would say our lower whisker, let's call it W, LW. It's going to be equal to the lower quartile 3 minus 1.5 times the interquartile range, 5. All right, we'll double check that. So it's going to be 1.5 times the interquartile range. Now that's going to end up in a negative space. All right. So if it ends up in a negative space, that means it's outside. All right, so this is going to be 3 minus 5 times 1.5 is 7.5, which is going to be negative 4.5. So that's way out, right? If we're looking at our upper whisker on that same token, it'll be equal to my upper quartile 8 plus 7.5. And we can see that's going to be 15.5. And 15.5 would mean that the data upper bound would be 15.5. Anything outside of that would be an outlier. And so immediately I can say, okay, therefore, our outlier is equal to 100 because it lies outside of the upper whisker. And with my lower whisker, it encompasses all the values that are there already. So now we can draw a box and whisker plot for this, or we can even just write a conclusion based on this for now. But the box and whisker plot would be, if we're going from 1 until 100, we can see that our minimum is 0, our maximum is 0. And then we had 2, 3, which was our lower quartile, and 4, 5, and then 6, and then 5.5 was medium, 7, 8, 9, and then we ended up with 8. Was it 8? 5, 4, 5, 6, 7, 8, which would be there. And you can see that that box is all the way on this side, which means that that outlier over there is kind of stretching our data set. It's giving us something that we don't want, actually. All right, so if I had to just draw it there, that line is way too long. And therefore, you can see that that would be an outlier. In this case, you would most likely leave it out, and you would not need it in our data set, and you'd bring everything back to until 9, and then change the data set, maybe find the median again, etc. So the spread in the box in whisker plot, all right, is the vital aspect that is conveying how data points are distributed across the range. So if we can understand spread, it helps us to analyze variability, identify outliers, and then make comparisons between different sets. Okay, so if we had to have another data set, which was over here, and extend it further, and maybe did not have that many outliers, we can see that the spread of the second data set here will be more than the spread of the first data set. And you would say, well, that's because of the interquartile range. Interquartile range would mean that it's more spread. Another thing is that my minimum and my maximum, which gives me my range, also indicate that the data is spread across the broader range. And my interquartile range is spread across the broader range as well. And we would then talk to that on that lines. Right. So that's an in-depth of spread using outliers and whiskers. The general rule is that using the interquartile range, we can use that as a mean